Now this compound C2H5ONa is called sodium ethoxide. So basically the type of questions which they ask is, you have a compound A and a metal B, and A plus B gives rise to effervescence. You know what effervescence is? Effervescence means the evolution of gas. So what are A and B? B is a metal, it's given, and suppose A, it's given that A is an alcohol. So we know that alcohol, I mean, you can get a faint idea that alcohol and metal, when they will react, they will give effervescence of hydrogen. So this alcohol should be ethanol and this metal should be sodium, and the effervescence should be of hydrogen gas. And one nice way to remember this reaction, if they just write simply C2H5OH plus Na, and suppose you forget the products. So what you do is that take this C2H5O this is the same compound, and you have Na and Na, break this bond, take this H2 out, and since oxygen has a free bond now, add these Nas to the oxygens. So it will give C2H5ONa and H2. Now, okay, balancing this reaction, if you see, this will be the balanced reaction. Yeah, don't leave the reaction unbalanced when you are asked. Always balance your reactions. So they might also ask that a sodium metal is dipped in ethanol. What will happen? So basically you have to write that hydrogen gas will be evolved, and what will be seen will be effervescence. Now there is one more reaction of ethanol. Actually there are several, we are studying only few reactions, which is if we have concentrated H2so4. Okay, and this is the temperature is 443 Kelvin. You remember this temperature. They might ask what temperature it is, or they might, when they ask you to write the reaction, you have to write this temperature. So remember this 443 Kelvin. So what should it give? Logically, this concentrated H2so4, what does H2so4 do? Concentrated H2so4. It burns away things. And how does it burn away things? By taking out the water. So actually, when concentrated H2so4 falls on your skin, it takes up the water of your skin, and what is left behind is just the carbon and the carbon containing compounds. So this H2so4 will do the same thing with ethanol. It will just take out water. And how will it will take out water? Let us see. It will just take out one hydrogen from this carbon and the OH from this carbon, and this H and OH will form your water. and now this carbon has one bond remaining, and this carbon has one bond remaining. So what it will do? One bond remaining, it will just join the two and make a double bond. So basically this will give C2H4. And what is this compound? Ethene. Don't try to remove hydrogen and H and OH from the same carbon atom, because that will not do. It will have two bonds left, and then it will not be able to form any double bond. It will not be able to form any bond only. You remove one hydrogen, and this is what actually happens. One hydrogen goes out from this carbon, the OH group goes out from this carbon, they make H2O, and then the remaining electrons which are remaining, because when a bond between this breaks, hydrogen will take away one electron and one electron will remain with carbon. And when this breaks, OH will take away one electron and one electron will remain with carbon. So these two electrons will form your double bond. So basically, just remove hydrogen from one carbon atom, the carbon atom not containing the OH group, and the OH group also you remove from the other carbon atom, and just join the two carbon atoms with a double bond. So this will give ethene and obviously water. And this is balanced. So in this they might ask you that ethanol on subjection, they might ask you to find the reagent. Ethanol on subjection to X gave this product. What is X? And what is the temperature at which the reaction occurs? So you realize the product, the reactant ethanol forms the product ethene, and it should click that the reagent has to be concentrated H2so4 and the temperature is 443 Kelvin. So X will be concentrated H2so4, temperature is 443 Kelvin. So this is all about your ethanol. We will be limiting our knowledge to this much. Now we have our next compound of concern. Ethanoic acid. Now ethanoic acid is basically, as I told you, commonly called acetic acid, and its formula is CH3COOH, and its structure we know is this: C double bond O, single bond O, H. So now one thing about ethanoic acid is that it is the vinegar which you get, which you put in your pickles and all, which tastes very sour, is nothing but diluted acetic acid. It's just acetic acid mixed with water. Pure acid. It's not pure acetic acid again, because it's very concentrated. So we have to mix it with water and make it dilute. So your vinegar is acetic acid, and acids taste sour. So we have the vinegar will also taste sour, and it does taste sour. Now this acetic acid will also have a very low boiling, it will have a high boiling point compared to the other organic compounds. It has a higher boiling point than ethanol also, but still it is liquid at room temperature. Ethanoic acid vinegar is liquid at room temperature. And you will see that when the temperature goes low in winters, this vinegar or acetic acid freezes. And because of this property of acetic acid, it is also called glacial acetic acid. So you can imagine how low the other melting points and boiling points of the carbon compounds will be. This is one of the highest melting point and boiling point of organic compounds. Now, what if you have acetic acid and you react it with ethanol? What do you expect? And okay, the reagent is dilute H2so4. Now H2so4, whether it is dilute or concentrated, it will always remove the water. Or in general, you'll just say H2so4. It's better to say just H2so4. So H2so4 will again remove the water. But in this case, the water removal will be from these two molecules. With only alcohol, it was from the single molecule. One hydrogen goes from this carbon, one OH goes from this carbon, and it forms ethene. But you have another compound over here. So this CH3 COOH and this OH, or I should write it like OH in this, the water is removed in this manner. H2O. See? H from this and OH from this. And what you get just remove this water and join the bonds. Is this compound. CH3 COO C2H5. And this compound is called an ester. I mean, these type of compounds which have this COO type of groups are called esters. And the name of this ester is methyl ethanoate. Now, we will not go into the naming of the esters. It's just methyl ethanoate, because there is one methyl group, there is one ethyl group, and the suffix for ester is O8, so it's methyl ethanoate.